Hello everyone, my name is Ameya Jagtap. I am a MSc Part 2 microbiology student from Modern College Ganesh Khind, Pune. Today I will be explaining the concept of bioremediation, two types of bioremediation, and the disadvantages and advantages of bioremediation. Coming, to, Coming towards the introduction, in early times, we believed that we had an unlimited abundance of land and resources, especially the non-renewable resources. In today's world, in greater or lesser degree, our carelessness and negligence in using them is very evidently visible. Contaminated lands generally result from past industrial activities when awareness of the health and environmental effects connected with the production, use, and disposal of hazardous substances was very less known and recognized rather than today. The conventional techniques used for remediation were to either dig up the soil and fill the land with our waste or to dump it in rivers and other aquatic sources. These methods have many drawbacks. The first method of dumping and landfill simply means to move the contamination elsewhere and create significant risks in excavation, handling, and transport of hazardous material. That is, to litter the other place from the first place. Additionally, it was very difficult and increasingly expensive to find new landfill sites for the final disposal of material and dumping it in the land. Dumping it in water bodies made it worse for aquatic life as well as humans. So, what is bioremediation? The term bioremediation basically is a better approach than these traditional methods is to completely destroy the pollutants if possible, or at least transform them into innocuous substances. Bioremediation is an option that offers the possibility to destroy or render harmless various contaminants using natural biological activity. As such, it uses relatively low cost, low technology, low techniques which generally have high public acceptance and can often be carried out on site. Bioremediation broadly refers to any process wherein a biological system, typically involving bacteria, microalgae, fungi, and plants, living or dead, is employed for removing environmental pollutants from the air, water, soil, flue gases, industrial effluents, etc. in natural or artificial settings. Typically, bioremediants involves oxidation. Oxidation enhances the water solubility of organic compounds and their susceptibility to further degradation by further oxidation and hydrolysis. Ultimately, biodegradation converts hydrocarbons to carbon dioxide and water, as you can see in the given diagram. For heavy metals, bioremediation offers few solutions. Metal containing pollutants can be removed or reduced with varying bioremediation techniques. The main challenge to bioremediations is the rate. The processes are very slow. So, now we come towards the factors of bioremediation, or the factors that affect bioremediation. The control and optimization of bioremediation process is a complex system and has various factors involved in it. These factors mainly include existence of a microbial population capable of degrading the pollutants, the availability of contaminants to the microbial population, the environmental factors, that is type of soil, temperature, pH, presence of oxygen or other electron acceptors, and the main, that is nutrients for the microbes. Microbial growth and activity are readily affected by pH, temperature, and moisture. Although microorganisms have been isolated in extreme conditions, most of them grow optimally over a narrow range, so that it is important to achieve optimal conditions. Below given is the table which explains all these points in detail. Now we turn towards type of bioremediations. There are mainly two types of bioremediations: ex situ and in situ bioremediations. Different techniques are employed depending on the degree of saturation and alteration in an area. In situ techniques are defined as those that are applied to the soil or groundwater at the site with minimal disturbance. Ex situ techniques are those that are applied to soil and groundwater at the site which has been removed from the site via excavation or pumping. Bioaugmentation techniques involves addition of microorganisms with the ability to degrade pollutants. Coming to the first ex situ bioremediation, which is land farming. The land farming is a simple technique in which contaminated soil is excavated and spread over a pre-prepared bed and periodically tilled until pollutants are degraded. The goal is to stimulate indigenous biodegradative microorganisms and facilitate their aerobic degradation of contaminants. In general, the practice is limited to the treatment of superficial 10 to 35 centimeter of soil. Since land farming has the potential to reduce monitoring and maintenance costs as well as cleanup liabilities, it has received much attention in the disposable alternative. The second technique is composting. Composting is a technique that involves combining contaminated soil with non-hazardous organic amendments such as manure, agricultural waste, etc. The presence of these organic materials supports the development of a rich microbial population and elevated temperature characteristic of composting. The third technique is use of bioreactors. Slurry reactors or aqueous reactors are used for ex situ treatment of contaminated soil and water pumped up from a contaminated plumb. Bioremediation in reactors involves the processing of contaminated solid material, that is soil, sediment or sludge, or the water through an engineered containment system. A slurry bioreactor may be defined as the containment vessel and apparatus used to create a three-phase solid, liquid and gas mixing condition to increase bioremediation rate of soil-bound and water-soluble pollutants as a water slurry of the contaminated soil and biomass, which is usually indigenous microorganisms capable of degrading target contaminants. Then we move towards the in situ bioremediation techniques. The first technique in situ bioremediation is bioventing. Bioventing is most common in situ treatment and involves supplying air and nutrients through wells to contaminated soil to stimulate the indigenous bacteria. Bioventing employs low airflow rates and provides the only amount of oxygen necessary for biodegradation while minimizing volatilization and release of contaminants to the atmosphere. It works for simple hydrocarbons and can be used where the contamination is deep under the surface. The second technique in situ bioremediation is biosparging. Biosparging involves the injection of air under pressure below the water table to increase groundwater oxygen concentrations and enhance the rate of biological degradation of contaminants by naturally occurring bacteria. Biosparging increases the mixing in saturated zone and thereby increases contact between soil and groundwater. The ease and low cost of installing small diameter air injection points allows considerable flexibility in the design and construction of the system. The third and last in situ bioremediation technique is bioaugmentation. Bioremediation frequently involves the addition of microorganisms, indigenous or exogenous, to the contaminated site. Two factors limit the use of added microbial cultures in land treatment unit. Non-indigenous cultures rarely compete well enough with indigenous population to develop and sustain useful population levels. And the second, most soils with long-term exposure to biodegradable waste have indigenous microorganisms that are effective degraders if the land treatment unit is well managed. Now we will turn towards the advantages and disadvantages of bioremediation. The major advantages included are it can be done on site. That is, you don't need to transfer the pollutants anywhere else. They will be done, the bioremediation will be done on the spot. It also involves a major factor of permanently eliminating the waste, that is, the waste will not be generated again. Biological systems are way cheaper than the conventional remediation techniques. The public has accepted these techniques and gives a very good response. It also reduces transportation costs and liability, and it can be coupled with many other techniques to give better and efficient results. Some of the disadvantages that bioremediation has is some chemicals cannot be bioremediated. That is, some chemicals are so toxic that biological agents cannot degrade them. Another disadvantage of bioremediation is it needs site-specific requirements. That is, there is no common protocol to perform bioremediation for all types of waste. It requires specificity. Toxicity of contaminants can also destroy the culture of microbes. Potential production of unknown byproducts is also a threat caused by bioremediation, as secondary products produced by microorganisms can lead to harmful pollutants as well. Thank you.